This conference will now be recorded.
Hello friends, welcome back to the next session. Today we'll look at applications of data science. It's kind of an section in which we are trying to understand the basics of data science and especially the foundations of how the different applications work. Let me open a presentation. So I have a small presentation for this one. Sorry, I did not get the question. What is core data science? So today we will look at applications of data science. So first things first, data analysis, data science, all these terminologies, like they were having different terminologies, but they were available for many, many years. It is not like, this is a very new thing which has started just few years back and a lot of people started working. It's not like that. Data analysis was there for many years. But something has tremendously changed in the past few years, which is giving a lot of push for the data related work, data analysis or data gathering, storage, computation. Likewise, a lot of things are happening in the past. So this is not the first time the data analysis was done. A lot of people worked on this for many, many years. Different variants of data analysis has started uh, with respect to exploration, business intelligence, creating algorithmic processing using machine learning and so on. So it's not new. It's pretty old topic, but something has fundamentally changed in the way the data analysis is happening. We will see what that is. So if you take the hype cycles of AI, so there is like AI hype cycles and AI winters. So in the earlier years of, let me take the pen. So in the earlier years, around 1958 or so, the initial AI models were invented, which are called as perceptrons. See, these perceptrons basically are yes and no kind of a models. They are like binary models, which were initially invented for doing some binary operations, for doing some task related operations. In the earlier years of 1958, 1960, that's when the perceptron models were invented. But because there was no data available, so unavailability of data. So because of the unavailability of data, it went into something called as an AI winter. AI winter is nothing but people thought that this is going to change the world. It is going to be a next big thing. But after a few years, they realized that it's not going to work. That's basically called as winters. And typically AI winter is where, they thought that AI is not going to work because we don't have enough data and this is not going to work. Later in 1980s and so on, there was another hype cycle, and this was purely because of the CNN models. CNN models were used for image-based processing. We are trying to look at the images and trying to determine what digits, the handwritten digits, were there in the images. So that is what we were trying to look at it. So those are the CNN models. So the CNN models basically provide such kind of a facility where you have this hype cycle, and they are trying to create the handwritten digit based analysis. The data was available during this phase. There was good amount of data, but the problem is like there was unavailability of compute. I can say no compute. When you're taking large volumes of image data, you would require large, memory capacities, compute capacities. You would require such huge compute capacities. At that time, in 1990s and so on, they were not having such kind of compute capacities, the GPUs and the CPUs and even more costlier chips. They were not available. And because even if you have the good amount of data, because there was no compute, it has to go into the AI winter, the second AI winter. And now again, we are in the hype cycle. We are in the 2022. So we are in the hype cycle, and people are kind of guessing whether this is going to go down. I think yesterday also there was a question like, how many years would you think that this is going to survive? And the answer to that is this might not be a huge hype, but it is going to sustain for a couple of years. The reason is because now we have three things coming into picture. First one is big data plus cloud computing plus algorithms. So you have a combination of these three things coming at the same time. Big data talks about huge volumes of structured, unstructured data and ability to store that huge volumes of data. So we do not have the problem of unavailability of data right now. We are gathering large volumes of data, and thanks to internet, different other devices, connected things, so we are able to capture a lot of data right now. So we don't have this problem. Second, we don't have the problem of cloud computing as well. We have good amounts of compute capacity right now. With a click of a button, within a few minutes, you will be able to launch huge instances without any delay. There is no issues of provisioning, there is no issues of procurement. All those things are not there. Thanks to the cloud computing, within a click of a button, we will be able to launch huge instances. And they're having GPU capacities, TPU capacities, and large volumes of chipsets are there from a memory perspective, from a compute perspective, from a storage perspective. So we have that facilities available right now. And the third one is, thanks to the algorithms, a newer set of algorithms are being created. Big companies like Google, Facebook, and other big startup players are kind of contributing to the open source community for creating algorithms, and they are launching it for free. So those three things coming together are kind of creating a positive environment, which says that, because we have all these things together at this point, this is going to sustain for a longer duration of time. Now, I can't commit that, it would be 5 years, 10 years, but this is going to sustain because there are a lot of applications coming into picture, and we have the flexibility of all these things. So this is going to sustain for a longer period of time. So this hype is going to sustain and going to continue, and can hugely benefit by creating applications in the data science space. So this slide shows like how the data is increasing every year. So this is a little old slide, but we are seeing that the data is growing tremendously every year into petabytes, zettabytes, and exabytes, and so on. And there's a huge collection of data right from different sources. So the data is being collected from different sources, and we are gathering the huge volumes of data. And now we have the ability to apply data science and do some processing on that data. If you take a step back and see like what is the data? What is the data which we are trying to do operations? The first one is the transactional data. The transactional data is a data in which we try to do a regular transactional processing. For example, it's a retail company. The regular transactions for a retail company will be like how many order or how many products are sold, what products are sold, what is the quantity of the products, the ones which are in demand, once the products which are not in demand. So such kind of analysis will be done. So the regular data will be like the regular transactions. So you go to a store, you purchase certain things, so that data will be captured. Typically, transactional data will be captured in structured informations, structured tables. For example, RDBMS tables like Oracle, SQL Server, MySQL. So these are some of the databases where you will be storing the structured information, and a lot of transactional data is being used for our business analysis also. So most of our data, I would say like 80% of our data would be transactional in nature, and most of our data analysis will happen on the transactional data itself. So there are a lot of work happening in the space, like how do you get insights from the data, how do you show some kind of dashboards, how do you present some business intelligence, create some reports and share those reports. So all this work is done in this transactional data space. And that is the first type of data. Next set of data types are audio and experimental data. Now I have clubbed multiple things together. So audio data, you're very familiar. Nowadays, you're seeing that there are a lot of audio devices coming into the market. For example, you take Alexa or Cortana or Siri or whatever. You can talk to those devices. For example, you say, Alexa, hey Alexa, what is the weather today? When you're saying this, a lot of things are happening behind it, right? So first, Alexa should understand what you're saying. It should wake up with the hey Alexa command, and it should understand the question. The question has to be converted from a speech to text-based format. what is the weather today is the question. So that has to be converted from speech to text. So there is some processing happening there. And once it is converted into text, then it has to call some kind of a backend query engine, maybe some Google or Bing or whatever query engine we call to get that information. Imagine today's temperature is 22 degrees centigrade or whatever. So you get that information back saying that today's temperature is 22 degrees centigrade, and that you get it from the query engine. And then from that, you have to convert that textual data into a speech format, maybe a voice format. So there are multiple pieces in this equation. So when you are speaking to the chat voice bots, so there are multiple equations. So you have to convert into, first you have to understand the text, convert into speech to text, then call the appropriate appropriate engines, then get the information, then convert to text to speech answer. All these things are combined. There are a lot of work happening in the space because speech analysis is very nascent. If you remember in the early years when the Siri was launched, there were a lot of funny videos where people talk to Siri, and it used to interpret in a different way, and people used to create some funny videos on that. But now if you see, it has matured so much, so even if a small kid speaks to the Siri, it will be able to understand and can respond accordingly, right? If you see the small kids right now, if they are able to speak, they don't type it, because for typing they need spelling and other things. For example, they want to put some games or put some songs on YouTube, so they will just use the audio option, right? So they click on the audio option and then they speak, and they know that it will go and search based on the audio option and get back the results. So if you have observed the kids, they do this way. So the audio based data analysis is being increasing. A lot of applications are being created right now. In the future, we will see that we will see systems which are created where we will directly talk to the devices. Maybe you talk to your fridge, you talk to your TV, you talk to your fan. In the future, you will see that every element will become an individual unit, and you will be interacting as if you are interacting with a human to that. Another area is the experimental data. Now, experimental data can be used in multiple areas. Now, I can take the example of COVID-19. For example, you want to release a new vaccine or maybe a drug for COVID-19. You can't directly release the drug just as it is, right? So it has to go through a stringent testing procedure. There are a lot of testing procedures, there are a lot of authorities which will approve the drug, and all those things has to be happened. Because if not, then if there is some kind of loss, either some kind of side effects or loss because of the drug, that will hugely impact. So people don't want to take that risk, and there will be lots lawsuits and other things. So especially the pharma companies don't want to take that risk, so they follow a lot of stringent procedures for the testing process. So they will test it on different animals, then they would do some clinical trials, and if once everything is successful, then they will do something called as sample based testing. Imagine there are 1,000 patients who are impacted with COVID-19. So they want to test this new drug which will cure the disease. So they will test on first 100 people. So 1,000 people are there, so they will test on a sample of your data. So 100 people they will test, and if that 100 people are behaving positively, then they extrapolate the results to the 1,000 people, and then say that because these 100 people are responding positively, and the drug is curing the disease, then you can extrapolate this to the entire population. That's how it works. So this is basically called as inferential based testing. So it's called as inferential statistics, one of the primary field of statistics, where we try to take some samples, apply on the samples, and see like how the samples behave, And based on the sampled results, we will extrapolate the results to the actual population. Now, this I have taken the example of a healthcare, but this can be applicable to any area of science. Maybe it is oceanic research or earthquake management system or uh, satellite or NASA or whatever, right? So depending upon a lot of experiments which will get get created, we can use that experimental data and use data science on that. Another interesting area is video and image data. And this is becoming very popular in these past few years, I would say. A lot of analysis is being done on image data and the video data. Now, let me take an example of image data. If you have looked at Google I/O's speech, Sundar Pichai's speech in, I think, 2017 or 18, he has specifically mentioned on how Google is working on something called as diabetic retinopathy. Diabetic retinopathy is a rare disease in which you would be losing your eyesight. If your diabetic levels are increasing, then slowly you will be losing your eyesight, and there will be like if you look at the retinal images of the eyes, then you see that there are some small spots which can be identified, which are caused due to the diabetes. So what Google has done is Google has created an application called as Verily, and they have tied up with two hospitals in India. One is Shankar Netralaya, and the second one is Arvind Eye Hospitals. So what they have done is they have given the device which basically scans the retina of the people, and then based on the retinal scans, it can analyze whether that particular retina is having diabetic retinopathy or not. If the disease is not treated in advance, then you can identify the disease and you can treat in advance. If it is not treated in advance, then slowly people can lose their eyesight. So that is a major problem. People think that because of the age or something, they are losing eyesight, but the real reason is because of their diabetes. So it is kind of used in multiple eye hospital, and it is kind of used in multiple areas, and it is used for a lot of advancement. So there are a lot of similar projects which are in the healthcare space, which are in the retail space, which are using computer vision. So we are trying to enable computers to look at the real world and can take decisions based on that. You can also see like self-driving cars, which are having 360-degree cameras. They also, take some sensory information from these cameras. So they look at the real world and they treat the real world imagery as a signal for their behavioral purpose, right? For example, there is a red signal, and the self-driving car should stop, right? Now, how does it know that there is a red signal and it should stop? That's because of the way in which the systems are designed, and based on all these internal conditions, it should take that signal and then it should stop. Connected to it is the video data. Now, video data is an extension of image data. Images are like simple one slide of pictures or frames, but video data is a connection of connected frames. So if you say like 60 frames per second, 24 frames per second, so what does we mean is like 24 frames are kept one after the other, and you are kind of creating a illusion of a video, like a moving image. Now, video data is also very interesting. Now, looking at the video data, we can take a lot of decisions. So there is a research work happening. IIT Hyderabad and the Municipal Corporation of Hyderabad, they are coming in collaboration, and they are doing some research work in which they take the traffic feed data. For example, every signal junction is having traffic CCTV cameras, and they take the feed of those CCTV cameras and they scan for people who are not wearing helmets. For example, you're driving on a bike and you're not wearing helmet, typically you will be fined. There will be some kind of a ticket or challan which will be cut on you, and you need to pay that fine. But for doing this task, there are a lot of there are a lot of people who are sitting, just taking pictures and taking the images, downloading them, looking through them, and then identifying who are wearing helmet, who are not wearing helmet. So this is a tedious process, and it takes a lot of time, manual effort and time for identifying that. And because of that, many people, because of sheer laziness, many people don't do their work properly, right? So to avoid all these problems, we can use a technology in which we can get the CCTV feed from the traffic signals itself, and it can directly scan through people who are wearing helmet. So there are systems which are created which can identify whether the person is wearing helmet or not, and if he or she is driving a two-wheeler. Then once it identifies that, it can also scan the number plate, and from the number plate it can gather the information, and we can put a ticket or a fine on that number plate. So whoever is driving it, they will get a challan, and they will get a message on their mobile number if they're linked with the number plate, saying that, because you are not wearing a helmet on so and so signal, so and so date and time, this is the photograph, and you are fined for that. Please pay it, or else after a few months, your license will be cancelled. So such kind of information is going back to the users, so that they are attentive, they follow the rules and all that stuff. These are some of the examples, but sky is the limit. There are a lot of things which can be done with image data and video data, and we can analyze that information. And there is a specific sub area which is created, which is called as computer vision. There's a lot of analysis happening on the computer vision, uh, where a lot of projects are created, and we see a lot of a lot of uh, buzz around that. Another type of data types are specifically the charts and the images and the graphs and so on. Now, picture speaks more than 1,000 words. Imagine you're giving like one full Excel sheet of 1,000 applicants, and we are giving the insights of 1,000 applicants in an Excel sheet with all numbers. You will not be able to make any sense of those numbers. It would become very difficult unless until you are expert in that area. It becomes very difficult for you to make sense of that numbers. But instead of that numbers, if you are given some images, for example, some charts, some graphs, some patterns, then what you see is that you will be easily able to make sense of the charts. You will see some kind of pattern happening, you see some kind of trend happening, you see some kind of structuring or grouping happening. Based on that, you could take some meaningful guesses that what the data is conveying. So similar kind of data is also there in terms of charts and graphs and network connectivities. So you can use that data for analyzing your information. So far what we have understood is there are different types of data types. There are different types of patterns, charts, graphs, all those things are there, and different types of video data, image data. We have traditional transactional data. All those things coming together will create a system in which you can analyze the data. These are about the different data types. So let us go forward and understand what is artificial intelligence, what is machine learning, and what is deep learning. Many people will have this kind of a doubt, like, what is AI? Is AI and ML different? Do I need to learn separately? So this kind of doubts people will have. So let us try to break that break that understanding right now. Just a second. So first things first, we will try to understand about what is AI. So artificial intelligence, initially it started with the thought that can we make computers do the work of humans? So that's the very, very basic thought, that can we make computers do the work of humans? Can a computer do what humans are doing so that humans can be relieved from the regular drudgery of a lot of manual work, boring work, and they can do something productive. But for doing that, you need to have some kind of set of rules and logics and so on. So artificial intelligence is an area in which it is making computers do the work of humans. For example, a human in a warehouse is taking a piece of cardboard. Imagine the purpose of the human. He has to take a piece of cardboard and then he has to make boxes or carton boxes out of it. You get these Amazon packaging boxes, right? So to make a box like this, you take a piece of cardboard and then you have to make a box like this. But to do this work, there are certain rules. So you will be, imagine you've got a trainee who has to work on this. Then you would say like, okay, take the cardboard and then fold it like this, equal proportions, and then fold it like this, and then turn it around, and then twist it, and then you can make a box like this, right? So there will be some set of rules of like how do you fold. Maybe you fold like this, and then you fold like this, and then this way and this way, right? And finally you make this box. You're getting it? So there are some set of rules which are governing this actions, right? So you say like, okay, take turn left, turn right, and fold it to the left, fold it to the right, and then you can make this box. So you need some set of rules, some logic, some decision points, right? So there are a lot of things which are required. So you need set of rules and logic and decision points, some set of conditions which need to be met for the certain task to complete. So artificial intelligence is all about creating uh, those rules and logics and things, so that those rules and logics can be coded to computers, and then computers will follow this exact set of rules and logics and then act on a certain task. So in the earlier industrial revolution, where you're kind of bringing the automation, the initial thought was to bring that automation and make computers do the work of humans. That was the initial thought. And that's how the AI came into picture. So artificial intelligence came into picture, where it can take the work of humans and then humans can be used for something better. That is the initial thought. So you can think like AI is an umbrella. It's a more of a general thought process in which we're trying to make computers do work of humans. That's good. Then what is machine learning? Machine learning is a subset of AI. If you think AI is an umbrella, machine learning is a subset of AI which goes deeper. Now these rules and sets are very, very simple, right? So we know like how this rule get applied, and if you follow the step 1, step 2, step 3, then you will be able to create this box. This is very easy. But what if you have 1 million data points? What if you have 100 different conditions, and based on 100 different conditions you have to arrive at a decision? I want to uh, I want to approve a loan for a applicant, approve or reject a loan for applicant. Now there are a lot of conditions. For example, the age of the person, marital status, kids, liabilities, current existing EMI, the salary the person is getting, right? Lot of conditions, right? Law based on all these conditions, we have to arrive at a decision saying that whether the person is can be given loan or not. And imagine you have say 1 million such data points. When you have 1 million records and 100 different data points, then it becomes humanly very difficult to create that rules. So in the AI, what we thought is somebody has to give these rules and set of logics. So an SME is required for giving those rules and logics so that such kind of output can be created. But when the data is increasing, when you have a lot of complexities, a lot of conditions and all those things, humanly it becomes very difficult to set those rules, create those logics. So in those cases, we can take help of statistical techniques. So ML is a mechanism in which we take the help of statistical techniques to create those set of rules so that the machines or computers can be enabled to take some decisions, take some predictive decisions on your data. So instead of humans giving the logics, humans giving the steps, SMEs giving the steps, we take the help of statistical techniques, some data related techniques. We can find out the similarities of the data. We can find out which data is causing some outcomes of some kind of output. So you try to understand the patterns between the data, you try to understand the conditions or relations between the data, and then based on all this information, we can come up with some kind of a generalized output. That is called as machine learning. Now, machine learning is an area we will learn very deeply in our course. That this is the area where we are trying to use statistical techniques to analyze large volumes of data, and with that analysis we can come up with some outputs. So it is a subset of artificial intelligence. ML is a subset of artificial intelligence. Next comes is deep learning. Now deep learning is one of the newer areas. Now deep learning is one algorithm of machine learning. Like as machine learning is a subset of AI, deep learning is one such algorithm of machine learning. Machine learning has a lot of algorithms, tree-based algorithms, graph-based algorithms. You have different ensemble techniques. A lot of algorithms are there. And one such algorithm is neural network, which is also called as deep learning. Now, deep learning is specialized in data which is unstructured in nature. Machine learning, mostly it is structured in nature. It needs to have clear-cut rows and columns. It needs to have very clear-cut data points. That's how machine learning is trained for. Whereas deep learning is specialized in data which is unstructured in nature. For example, speech, images, video data, right? Textual data. So these are some of the data types which are unstructured in nature. And when you want to analyze such kind of unstructured pattern of data, then you would use deep learning. It is a subset of machine learning, and it is comprising of some kind of algorithms which are basically neural network based, and they will be specialized in doing image recognition, speech conversion, language conversion. So all these kind of tasks can be used by neural networks, and that area is called as deep learning, right? So now you might have got a clear understanding of what is artificial intelligence, what is machine learning, and what is deep learning. These different areas you might have got a clear understanding. But you might have still have a doubt like, now Sitaram, this is all good, but what is data science then, right? So where is data science coming into picture? Now data science is connecting all the pieces. For example, if you look at it, this looks to be like the central piece, like the modeling or algorithmic part of your entire data science. But somebody is feeding the data to this, right? So there will be some systems which are feeding data to this, like I can say like data ingestion. There will be some systems which are transforming the data transformation. There are some systems which are exploring the data, like trying to find out patterns, graphs, and charts. You can call it a data exploration or exploratory data analysis, right? Or different names are there. So we are seeing that somebody is ingesting data to this, somebody is doing some transformation, somebody is trying to analyze the data, explore the data, create some graphs and charts and comparative analysis. Somebody else is doing it, right? Somebody needs to create an output model, so data modeling. Somebody needs to you know monitor this entire stuff, like how the model is performing, how the deployment is happening, how the model is changing over time. So you can say like monitoring, right? So again, the monitoring will be part of deployment, model deployment, I can say. So there are a lot of other things which are connected. So you are seeing that there are some peripheral areas which basically connect to the central piece. So that all peripheral areas, you can connect all the dots, and that is called as data science. Data science talks about right from the data ingestion till the model development and model monitoring. You can also identify drifts in the data, drifts in the model, and over the time, how you are building that entire system. That is all we call about data science, right? Understood? So any questions on this so far? So generally what I do is our sessions will be around 45 to 50 minutes. That is the general time frame we will have. And I will allow around 5 to 10 minutes for any questions. So sometimes it will be overboard. So sometimes it will go to 1 hour, even more than that. But generally the plan goes in this way, that every session planned in such a way that it would be around 45 minutes to 50 minutes, where most of the time I'll be going through the session. We will be running some experiments, doing some coding. Most of the sessions will be in that way. And once you get an understanding, I will allow another few minutes for any doubt clearing sessions. If you have any doubts, we will be discussing on those topics. And I would encourage, like, if you have any questions in between, you can also put that in the chat window. So the chat window is available, so that you can put that in the chat window, so that I can look at the questions and I can answer them while we are having the session itself. So I don't have to stop and break and then take the question and then come back. So I will not do that. As the session progresses, I will be looking at the questions and I'll be answering them when required, right? So that's the way I will be following. So I have so any questions on what we discussed so far? Is it clear? So what is CNN modeling? So CNN modeling is like called as convolutional neural network. It's basically for doing image-based analysis. So I gave an example of diabetic retinopathy on human retinas, right? Human eyes. So you take a sample of a retina and then you try to identify whether there is diabetic retinopathy or not. So for doing that, we apply a lot of CNN based techniques. It is a subset of deep learning based algorithms. Those will be used for doing image based analysis. So there's a question like, in ML, does the machine learns by itself? Yeah, machine uses a set of statistical techniques. Learning by itself, in sense, we provide them the data and we provide them the algorithm. So every algorithm will have its good and bad. So some algorithms can learn some way. So there are different techniques. Tree-based techniques are there. Uh, Distance-based techniques are there. Transformational techniques are there. So depending upon different types of techniques, they can interpret the data in a different way. So machine learns by itself is true to some extent, but that learns within the boundaries of the algorithms which are provided. So you provide a set of algorithms, it will learn according to the algorithms, and then it will come up with some kind of a generalization. So we will use the generalization for doing prediction. So deep learning and machine learning are same. Yes, they are same. They are the same set of techniques. Only thing that deep learning works specifically on unstructured data, where machine learning primarily focus on structured data. So that's one of the differentiator, but both are same. Both are doing the exact same thing in a different sense on different types of data, right? But deep learning and machine learning. So deep learning, in fact, is a subset of machine learning. It's one of the algorithm. Neural networks is the algorithm of machine learning, which is used for deep learning techniques. Any other questions?
You're mentioning the structured data, right, for the machine learning. That means only the transactional data or like the video and images?
Mostly structured data falls under transactional data or
Right.
data from flat files or database dumps, logs. We can also have semi-structured data in terms of JSON documents and YAML files. So we have some kind of structure, semi-structured, but primarily coming from tables,
Right.
databases.
So that data only for the machine learning, right?
Yes, correct.
Okay. So machine learning can be, I mean, my question is like if there is an image and video, so we have the machine learning algorithms also, right?
So for image and video based analysis, if you want to apply machine learning, what we have to do is we have to do something called as feature engineering. Feature engineering is an area in which if I give an image, now if I give an image of dog and I want my machine learning algorithm to identify that this is a dog. So how do I say that this image is of a dog? Now dog will have two eyes. You will give this feature saying that
Okay,
given
got
image, it will have two eyes, it will have 2 ears, it might have fur, and that fur can be white or brown or black or whatever. And you will give all the features. That's called as feature engineering, and that technique will be done. And you will have some input mechanism where you pass the image and the features will be identified, and those features will be given to the model, machine learning model, and based on the features, it will identify whether it is a dog or not. Right. So that
Okay.
is how it works. But in deep learning, we don't need that feature engineering. We don't have to specifically say that okay, the dog will have fur, dog will have small eyes. You don't have to tell that.
Okay, got it.
Any other questions? All right. So I want to logically stop at this point. In the next session, I'll be talking about something called as applications of data science. Specifically, so mostly my presentations will not have any theory. You'll only see pictures, and I use very less presentations, one or two in the entire course. We'll only have one or two because this is much this is like an introductory thing. I'm trying to use the slides, but most of them will be extempore sessions. We will be going through scribbling and understanding the algorithm, and as if like a blackboard session, mostly it would be in that fashion. All right, so I'll logically stop it at this point. Tomorrow when we come back, I'll be talking about different kinds of applications with respect to predictive analytics, fraud detection, sentiment analysis, and all that stuff. So till that time, you take care and have a nice day. I'll meet you guys tomorrow at the same time. All right. Thank you very much. Bye bye.
Thank you.